Alrighty, howdy y'all. This is a recording of the Myco-Remediation class that I did for CTMS. Um, so the basics of microremediation is that you're using fungi to remove contaminants from our soil. And the way that I like to describe this is you're healing nature with nature. I'm Hector. I study biology and philosophy and specifically focus on love because I believe that love is central to both. And it's through love that we're able to communicate with one another. Um, and this communication, I like to follow this very specific process of starting with idea that fuels passion that leads to action. And then these actions create new ideas from which the cycle can start over again. And you do this over and over again until you have full human consciousness. And just really important to focus on these issues so that we can help the environment. Um, Normally, whenever people talk about recycling, plastic is obviously the main thing that people talk about. Uh, and you may think, what is the point of having plastic eating fungi if we already have recycling? But very little of recycled material actually does end up getting recycled, only about 9% of it. The rest is either incinerated or just goes back into the environment. Even with these landfills, the plastic just sits there for decades, um, and it won't degrade because that's a very anaerobic environment. There's no oxygen, so the plastic problem is still something that we are actively working towards, and I think fungi are able to hold the answer to that. And just a little more about bioremediation. So the important part with this is that you're using the natural processes that organisms already undergo as part of their metabolism and development. And you're tapping into this and working with those organisms so that they can fulfill their environmental niche, but localized into specific problems that we are working towards. And a few examples of that are phytoremediation, which is plants, bacterial, obviously, and myco, which is fungi. And that's going to be the focus of this presentation. And each of them have their own specific utilities that maximize specific areas. Like, for example, plants have these root systems that are able to filter out water and are really good at absorbing heavy metals into from the soil. And bacteria are able to break down hydrocarbons like plastics and oils and provide a biofilm. And fungi are able to do both of those things, but again, they really do work in conjecture with each other. Like, for example, you'll have a plant root that is being set, and at the same time, you have bacteria that's providing the biofilm that provides the moisture for the fungi to be able to also go in there, undergo its processes, and also maximize surface area, which is really important because the more surface area that you have, the better that you're able to do these processes. And the way that fungi are able to do this, it's just part of their natural life cycle. Um, Here you can see that fungi, the mushroom as we typically see, they drop these spores that after rain are sprouted into this mycelium or hyphae. And this is actually where the uh, remediation is undergoing. The fungi can either pick up heavy metals like mercury and sequester them into the fruits, or they provide enzymes for plastic degradation, which we'll go into shortly. And the reason fungi are able to do this is because they evolved to fulfill specific environmental niche before fungi were around to do their thing. Um, there wasn't any way to degrade trees, lignin specifically, which is the molecule that gives trees their structure. And uh, it's because of this that fungi are so important, because we have these white rot fungi specifically that are able to break down the lignin of the trees and it's this degradation of the lignin that gives the remaining tree sort of a white appearance, as opposed to brown rot fungi that focuses on cellulose and hemicellulose, which results in only lignin, and that's where you see the general brown bark esque tree features. And these are both saprotrophic fungi, meaning that they survive off of dead and decaying plant matter. And mycoremediation itself is fairly new when it comes to understanding these. Mycology as a whole is a very new science, and it's only been fairly recently that we've really been understanding the potential that fungi have. Most people have heard of Paul Stamets' TED Talk on how fungi can save the planet, and he talks about how he grew um, oyster mushrooms on piles of oils that where the fungi were able to essentially get all of their nutrients from those hydrocarbons. So this is something that has been studied. It's just the actual applicability sorry, of these fungi have been fairly underutilized so far. And some of the common ones that we that are studied pretty frequently are oysters, turkey tails, crust fungi, and molds, black mold specifically. And they each have their own specific way of breaking down these molecules. Um, and the important part with this is to understand that it's best to focus on local fungi. All of these have many species that grow all around the world, but it's still best to focus on the species that grow locally. For example, there's some yellow oysters that are not native to the United States that are starting to show up in forests in the Northeast because of mushroom farms that have been producing tons and tons of these every single year. And as part of conservation, which is the whole point of this, we really should be doing everything we can to make sure that we're not disrupting the balance in trying to fix these problems. And a little more tidbit onto the science. Energy cannot be created or destroyed, and that's the main part about the plastic, is that the fungi are recycling the plastic. They're as opposed to just kind of absorbing it into themselves. They're literally ripping apart the molecules so that they can use those atoms and the energy in the bonds for their own metabolism. And specifically, it's their secondary metabolism. The primary is the one that builds like ATP and glucose and whatnot, and the secondary responds to the environment. So if they come into contact with a specific substrate, they will then check like pH and composition and see which enzymes they need to, like they'll change the ratios of their enzymes so that they can undergo these processes. They're essentially training themselves to break down these substrates, and that's an important tidbit for later. And like everything, fungi are looking for essentially these four atoms: oxygen, carbon, hydrogen, nitrogen, and they're eating the plastic because the substrate that they're being grown on is nutrient deficient, and they're essentially being starved to where they need to learn and train themselves to eat the plastic. But once they're able to do that, then they can continue this process. And just to give you a little example as to the necessity for these four atoms, here's ATP synthase, which is what makes the mitochondria the powerhouse of the cell. This acts as a actual turbine that is being spun um, about 8,000 times per minute. And this is specifically from a YouTube channel called Clockwork. Really cool channel. Recommend them. They have a lot of really awesome animations when it comes to these natural processes. And this actually shoots hydrogen atoms, and the pull from the charge snaps this protein into a specific shape that causes it to rotate. So you have the hydrogen atoms there, obviously, and then all of these proteins, like all proteins, are made up of nitrogen, carbon, oxygens. And there's trace elements also, like iron, obviously, and phosphates and whatnot, but those only make about 3% of the rest of the organism. So the way that fungi are able to get these nutrients are from their enzymes. There's dozens and dozens of enzymes, but the three that I'm gonna introduce here, just to get an idea as to what these enzymes are doing, are lignin peroxidase, manganese peroxidase, and variable peroxidase. Lignin peroxidase acts on the surface of the lignin or the substrate. It uses a central iron molecule in the protein to essentially pump out electrons that can break down the lignin, as opposed to manganese peroxidase that actually is a penetrative enzyme. So it shoots out ions by changing their polarity so that they can go through these benzenes, which I'll cover in a second, um, and actually start degrading the wood from the inside out. And like with the different types of remediation, it's not just one of these. Realistically, the fungi is producing many all at once, but it's just they're regulated by what their substrate entails. And this is a little animation to show a lignin molecule, which is the structure of trees. And you'll notice that it has these hexagonal rings around them. They're called benzenes or phenol rings. And these are some of the most stable molecules in all of organic chemistry, which is what makes lignin so hard to degrade. Um, and you can see that there are these areas of electron density throughout the molecule. The red bits are where all the electrons are, where all the energy is stored essentially. But because the benzene rings are so stable, they're essentially blocking out all of those areas from the molecule so that the molecule itself just stays inert and is not able to react. But fungi use this process with their enzymes to create radicals, which are molecules or atoms that have unpaired electrons, unpaired lone electrons, and this causes them to be extremely reactive. So as soon as these molecules or atoms come into contact with essentially anything else, they will rip a lone pair from whatever molecule they interact with, which will destabilize the molecule. And this is essentially how it works. In reality, the electrons are zooming all around the molecule trillions of times per second. But just to give an idea, the radical will form at the edge of the molecule, which will then split into two radicals, which will cause a chain reaction throughout the molecule to break it down into smaller molecular fragments that the fungi can then absorb and use other enzymes to break down. And that brings us to my greatest and latest invention, the Myco-Recycler. Um, and this is a homemade bioreactor that you can make to convert plastic into carbon dioxide and water using the enzymes that we talked about with fungi. And it's very straightforward. What you need is a container, a culture of fungi, substrate, which there's a few different types of substrate that you can choose from, and plastic, and then just a few other household accessories to actually make the recycler functional. And what you're going to want to do is take the substrate and cold pasteurize it overnight. You can use lime powder from this, that's pretty readily available. And what it does is it lowers the pH to the extent that it kills off competing fungi and most bacteria, so that the fungus that you're introducing doesn't have to work as hard to decompose these plastics. And once you have it pasteurized, you're just going to clean the container, nothing too crazy, just some Dawn dish soap would be fine. Um, and you drill holes into the container, because it's important to remember that this isn't just a pile of trash and this isn't just a compost bin. This is a breathing, living organism that you're going to be taking care of. And as you take care of it, it will also take care of you. So the air holes are really, really important because you need air to survive. And you cover it with micropore tape so that it keeps out little critters, because you don't want bugs to come in and try to eat the fungus or accidentally introduce contaminants to the fungus. So you're going to layer the mushroom blocks on the bottom and just create a little lasagna of mushroom straw, and let that take so that it can set and grow and be healthy. And that'll take approximately 3 weeks. It depends on many variables, how much fungus you use, the size of the container, but 3 weeks is a pretty safe bet for this. And you're really just looking for the fungus to completely colonize the block. And once it does that, then you're able to introduce the plastic, uh, so that it can start learning how to eat the plastic. And you're going to want to start off small because, again, you're training the fungus to do this. It's going to be able to do it right from the get go, but if you introduce too much, it could shock the fungus to where it would just starve and would not be able to grow, or wouldn't be able to defend itself properly from contaminants. And the way to feed it is, once the fungus has been set, you break it apart and you just feed it with more straw and plastic. And it's best to keep the plastic near the top because that's where the oxygen is coming in. So that's where the fungus is able to do its enzymatic properties uh, the best, as opposed to near the bottom of it. And just a few reminders for this process, because again, it's super simple. It was just four steps in making this. Nothing too crazy. And what you're going to want to remember with this is that the smaller the fragment of plastic, the quicker you'll get complete degradation. And this bioreactor needs air. It needs oxygen because it's a living organism. And from this, it's able to use the plastic to fill nutritional gaps from this environment that you set up for it. And once you have it built, all you need to do is maintain it. Again, this is a living, breathing organism. So you need to let it breathe, both literally and metaphorically, in the sense that it needs air, but also it needs time, because this is not just a one step process. The key takeaway from this is that you're reducing the time of degradation for plastic from decades to weeks or months. Um, so that's a very drastic change in degradation time, but it's not an instantaneous process. And other than that, you're going to want to make sure that it's not getting contaminated. Look out for bugs. Look out for mold. Um, try to keep a constant eye on it with feedings, especially, just to make sure that everything looks good. Um, the idea with this is to keep it going indefinitely, so you will eventually run into contaminants, but getting rid of those contaminants isn't a very big deal at all. Um, you're gonna see the health of this fungus from just looking at it. It's gonna be white, slightly fluffy, a little damp to the touch, and it's gonna smell pretty good. Sometimes I've had it smell like sourdough bread, which was pretty nice, as opposed to mold that is gonna have distinct, blue, black, green, red, powdery appearance to them, and it's usually always gonna smell pretty bad or pretty funky. Um, so whenever you see that, all you're gonna need to do is cut it off and either throw it away or throw it into your garden bed, because molds are still very beneficial to soil. And then there's no research to show that it's dangerous to eat these mushrooms. It seems like the fungi are pretty able to break it down pretty good. But just to be safe, it's best to discard the mushrooms, to pluck them whenever you see them growing and then discard them. And this is something that can really be scaled up. The cool thing about this is that the science for this does scale up. And just to give you an idea of the potential impact for this, there's companies like Chip Drop that they will drop literal tons of mulch into your front yard, because wood is a byproduct of industry. And obviously, we produce billions of tons of plastic per year. So you put two and two together, and you have substrate and plastic that can be used for the substrate, to grow these fungi and do these remediation processes to degrade this plastic into something that can be used for the environment again. Because the plastic is being degraded completely into carbon dioxide and water, just like a lignin from a tree would. But in addition to that, these blocks themselves can also be used as building materials. They get pretty sturdy whenever they dry out. And there's also POPs, which are pollutant or persistent organic pollutants that form from wildfires. And they're structured pretty similarly to hormones that we have. So they can be hormone disruptors if they get into the food system. And they're very strong molecularly. They have a lot of those benzene rings, but fungi, as we saw, are able to break those down and degrade them into things that they're healthier. And even though we say not to eat the mushrooms, there have been some people that use the mushrooms for livestock feed, and it seems like the livestock still are doing fine from that. But with all of this, more research is needed, because even though we have a good idea as to different types of fungi and what enzymes they have, it's possible that there's a fungi in central Mexico that we've never heard of or never done a enzyme assay on that does this process 10 times quicker. So we really need more research when it comes to this. In addition to that, some things to keep in mind is that this isn't just a quick um, or solution to plastic, because this itself creates additional consequences, you could say. Um, this makes a fungal biomass whenever you are as a product of making this, and that's something to keep in mind. The fungus itself is biodegradable, so it's not as big of an issue as plastic byproducts, but it's still something that needs to be, like I said, kept in mind. And this is also why I focus on using local fungi, because if you do have a biomass of local fungi, that would likely not be as big of an issue as if you had an invasive species that was able to take in its new location. And the research for this, even though we need more, there is still enough research to show that this works. The only thing that we need to do is do it. Like I said in the beginning, the process is idea, passion, action. From this presentation, I have introduced new ideas to you guys, and I'm hoping that this impact brings about passion for us to do this, because it really is fairly simple. And there are some people that are already doing bioremediation in different ways. Here's a case study of them using inoculated logs to degrade fallen wood, and that helps with the forest fires in the area, because there's less fuel for the fires. And it shows that bioremediation isn't always just um, to do with like contaminants. There's it's just using fungi to help the environment in general. But that being said, there are also people like Danielle Stevenson that are using fungi for contaminants like heavy metals, and she works with fungi and plants to clean up these test sites or these destruction demolition sites, um, and properly recycle the material to material back. And that's also one of the benefits of this using this process, is that whenever there are demolition sites, generally they use heavy machinery to pick up all the debris and carry it to a landfill. And even in the process of doing that, the heavy machinery is depositing heavy metals just as a part of natural erosion on the machines. Uh, but when it comes to mycoremediation, um, it seems possible that you can plant a lot next to the demolition site, where you pile up a lot of the debris, and you use these processes of layering the fungi to be able to recycle the nutrients or get it to a safer, like oxidation state, for example, um, without having to use these heavy machineries to um, pollute the environment in the process of cleaning the environment. And this comes with challenges. Again, this isn't just a silver bullet. We found the answer. One of the big challenges is that even though this has potential for big impact, currently, like with the Myco-Recycler, it's just showing how you can do this at home. Um, an individual recycler would only likely be able to recycle a few pounds of plastic per year, depending on its size, which is fairly negligible. But if this was something that was scaled up to where people would use these to the same degree that they use their trash cans, now you're talking about billions of pounds of plastic that are getting properly recycled into safe molecules for the environment. And that's whenever we would see significant results. But again, more research is needed. And the way that I like to think about this is like Albert Camus comes to mind from The Myth of Sisyphus, where he says the struggle itself is enough to fill a man's heart, because the best things in life usually do come from struggling first. Um, and that's not reason by any means to get discouraged. If anything, it's more reason to show that seeing the fruits of your labor is a very rewarding process. And just a few final notes: don't eat the mushrooms. It's, as a safety precaution, we don't recommend doing that. But also have fun with this process. The science is there, but what we're currently doing is research as well. Try different substrates, try different fungi, different ratios, and just see what kind of results you can get. We would love to hear about these results. There's links to the social medias towards the end of the presentation, where you can tell us, just give us updates on what you're doing. And while there is possibility for fungi to remove metal contaminants from the soil, we do really recommend only using household plastics for this, because the process of getting the heavy metals out of the fungus creates its own byproducts that really should be dealt with professionally, um, as opposed to the plastic eating fungi that is fairly straightforward. And community is a huge part of this. We want people to do this. We want people to be aware and know how to do this and know how to put the work in. Um, so we really encourage people to reach out to us, and after making their own, seeing their results and sharing their results, so that we can really fine tune this to be something big. And last quote to finish this off. This is from Slavoj Žižek and his description of love, and I feel like this was very applicable. He says, "What is love? Love is not idealization. Every true lover knows that if you really love a man or a woman, that you don't idealize him or her. Love means that you accept a person with all its failures, stupidities, ugly points, and nonetheless the person is absolute for you. Everything that makes life worth living. But you see perfection in imperfection itself, and that's how we should learn to love the world. A true ecologist loves trash." And like I was showing earlier, energy cannot be created or destroyed. There is potential energy inside of this plastic that can be accessed with fungi. Plastic is part of the environment, it's part of the natural world now. And like with love, we're not just looking at the good feelings that come from this. We're seeing the faults, we're seeing the shortcomings, and we're doing what we can, providing space to heal the environment and show our love and compassion. And here's the social media that we have. Like I said, we'd love if you guys reached out. The Our website also shows different programs that we're going to be doing on our calendar. And yeah, thank you so much for this presentation. I hope it was informative. Um, Adios. Howdy, y'all. So this is just a little example as to how to make a Myco-Recycler. I'm going to be making a Myco-Recycler mini with this little jar. And just for the sake of time, I already pre-drilled the holes on top and covered it with micropore tape. Micropore tape can be found in any pharmacy aisle. It's used for actually, I don't know what it's used for. I just used it for mycology. But what you're going to want to do is you're going to start off with the substrate, and you're just going to make a little pile on the bottom. This recycler that I'm using is fairly small, so don't need to go crazy with layers or anything. It's just enough to kind of get it going and for demonstrative purposes. And once you have a little layer of that, you're going to get your substrate. I am using straw, so I'm just going to add a little layer of straw. Again, don't need to go crazy or anything. It's not super necessary at this point to get it. All you're trying to do is get the fungi established, really. So pretty straightforward. And I already pasteurized this the night before. Again, that's pretty important to reduce contamination. But you just get a little layer of straw right there. And I said in the presentation that you want to hold off on the plastic to not shock the fungus, but just for demonstrative purposes, I'm going to show you how you would feed it with the plastic. So what I used was HEB plastic reusable grocery bags, because I have about 50 or so in my closet that I keep forgetting to take to the grocery store and getting more of. So I just add a little layer of shredded plastic in that way. But again, you can use whatever household plastic you have. Go nuts with this. Really experiment and see what kind of result you can get. And then once I have that, I'm just going to add an additional layer of the mushroom block to the top of it, so that it can be sandwiched in between and just help the fungus myceliate and completely set in this little mini recycler. I'll put a little more. And these mushroom blocks also, they're a byproduct of mushroom farms, so they're readily available. You can get pounds and pounds of these blocks every single day. And then once you have that, you just close it up. There you go. You have a little mini bioreactor that you can set on your desktop and see do its thing. And as a process, you're recycling plastic. So again, super straightforward process. I just want to get people to see that this is something that they can do at home, and try to have an impact in the world. So deuces. Also, last little tidbit. Again, this scales. So I have a slightly bigger bioreactor here that same process, layered it with fungi, layered it with straw, and then a little layer of plastic at the end. But you know, your imagination is the only limit here. So go nuts.